Today, we are diving into one of history's greatest technological mysteries, a lost computer, but it's not made of silicon, it's made of string. We're talking about the Inca Khipu, a device so far ahead of its time that for 500 years, the world just completely missed its genius. All right, let me set the scene for you. The year is 1532, November 16th, in the Inca city of Cajamarca. The emperor, a man named Atahualpa, is face-to-face with the Spanish conquistadors. They hand him a Bible. He holds it up to his ear, probably expecting it to speak, but he hears nothing. So he just tosses it to the ground. Now, Spanish history books will tell you this was the act of a savage. They were wrong. You see, this wasn't a clash of civilizations so much as it was a clash of information technology. Atahualpa lived in a world where knowledge wasn't flat, frozen in ink on a two-dimensional page. In his world, information was tactile. It was three-dimensional. It was literally woven into the fabric of space using a device called a Khipu. For half a millennium, that's 500 years, historians looked at these incredibly complex knotted cords and just dismissed them. They called the Khipu a primitive counting tool, something like an abacus, for basic bookkeeping and really nothing more. This view fundamentally misunderstood the intellectual achievement of an entire civilization. But now we know the truth is so much more incredible. The Khipu wasn't just some simple calculator. It was a fiber-based computer. Yeah, you heard me right. New research suggests it was this sophisticated system of 7-bit binary coding that let the Inca run a massive empire. We're talking 10 million people without ever writing a single word of text. So how on earth did this fiber-based computer actually work? Let's break it down.
So let's get into it. How did this ancient computer actually function? Well, it all starts with the hardware. But believe me, it's about way more than just knots.
Okay, the first thing you have to do is make a mental shift. You've got to stop thinking about writing. A Khipu isn't a sentence. It's more like a spreadsheet or a database, one capable of holding huge amounts of really structured information. So on the surface, the Khipu works on a system we all know. Decimal, or base 10. The knots down at the bottom of a chord, those are the ones. The knots a little higher up, that's your tens place. Then the hundreds, and so on. They even had a concept for zero, which they showed by just leaving a space, a deliberate lack of a knot. This is the part historians kind of figured out, but here's the thing, it's only the first layer. Because underneath that simple decimal system, an anthropologist named Gary Urton discovered a hidden binary layer. The data wasn't just in the knots themselves, it was encoded in the very fiber of the chords. Was the thread spun clockwise, what they call an S-spin, or counterclockwise, a Z-spin? Each one of those choices is a single bit of data, a 0 or a 1. And this is where the genius of the system really shines. The Inca layered multiple binary choices, one on top of the other. So you had the spin of the fiber, that's one. Then the direction the knot itself was tied was another. And even the way a smaller chord was attached to the main one, forward or backward, that was a third binary decision. Now when you combine all these layers of binary choices, what you get is basically a 7-bit code. And a 7-bit system can produce 128 unique combinations. That is more than enough for a complex alphabet, or, more likely, a really sophisticated system for classifying people, places, and things. They weren't just counting corn, they were encoding entire narratives and histories. Okay, so the Inca have this incredibly powerful data storage device. But, data is useless if it can't move. To solve that problem, they built something truly extraordinary, a human internet. The physical infrastructure for this network was something called the Capac Ñan, the Great Inca Road. We're talking about a 25,000-mile network of masterfully paved roads, some of them at altitudes of over 15,000 feet, connecting every single corner of their massive empire. And along these roads ran the Chosquis. These were elite relay runners stationed every few miles. A Chosqui would get a Khipu, sprint his section of the road, and then hand it off to the next runner. With this system, a message could travel 1,200 miles in a single week. I mean, just look at this comparison. That's faster than the famous Roman Post and way faster than America's Pony Express, which came centuries later. So what was the point of all this? Why build such a fast, complex system? Well, the Khipu network allowed the Inca to create what was basically a data-driven welfare state. The official keepers of the knots, the Quipucamayaks, tracked everything, every bushel of grain, every llama, every soldier. If a region somewhere was suffering from a drought, the central database knew about it almost instantly, and food was sent from government storehouses. They used data to virtually wipe out famine. So
If this technology was so brilliant and so incredibly effective, why can't we read Khipus today? Well, this brings us to the tragic third act of this story, the systematic murder of this incredible knowledge system.
After the Spanish arrived, it actually took them a few decades to realize what the Khipu really was. The turning point came in 1583 at the Third Council of Lima. The Catholic Church finally understood that these weren't just accounting tools. No, they were the archives of Inca religion, their history, their laws, the very soul of their civilization. And so they made a declaration. They called the Khipu the work of the devil. They were deemed idolatrous objects, a direct threat to the Church's mission to convert the population. An order was given: find every Khipu and destroy it. What happened next wasn't just book burning. It has a specific chilling name: epistemicide, the deliberate murder of an entire system of knowledge. They didn't just burn the cords, they hunted down the Quipucamayaks who could read them, breaking the chain of transmission forever. To really get the scale of this loss, try this thought experiment. Imagine if some outside force arrived today and systematically wiped every server, every hard drive, every single smartphone on the planet. That is the level of cultural and intellectual devastation the Andean world suffered. But the story doesn't end there, in destruction. Today, there's a global effort underway to reclaim this lost knowledge, to try and reboot the Inca's lost computer. And there have been these amazing breakthroughs. At a site called Incahuasi, archaeologists made a stunning discovery: a collection of quipus found buried with the actual goods they were cataloging, baskets of chili peppers, peanuts, beans. For the first time, we have a potential Rosetta Stone, a direct link between the data on the cords and the physical objects they represent. You know, the slow, painstaking work of trying to decipher the Khipu is teaching us a pretty profound lesson. It forces us to ask a really important question. What other forms of genius, what other entire systems of knowledge have we just dismissed or destroyed throughout history, simply because we failed to recognize their form? The knowledge wasn't lost, we just didn't know how to read it.